Here we have 10.3, which deals with ellipses. So objectives, use and determine standard and general forms of the equation of ellipse, and then to graph a set of ellipses. So ellipse is a set of all the points in the plane, the sum of whose distances from two fixed points, called the foci, is constant. So an ellipse has what's called axes of symmetry. The longest axis is the major axis. The foci lie on this line. The shorter axis is the minor, so major is bigger, minor is smaller. At the end point of each axis, you have the vertices. So one way to think about a circle is it's an ellipse that has the same length, major and minor axis. An ellipse, that does not necessarily have to be true. So here's just a lovely thing that's got all of the facts about ellipses, depending on whether they're oriented horizontally or vertically. This is in your notes. So example 1 here, consider the ellipse graph below. I write the equation of ellipse in standard form. So to do that, we need to find values for h, k, a, and b. So h and k are at the center, so this ellipse has a center at 2, -4. So a is the distance from the center to the edge long ways, so it's 1, 2, 3, 4, 5, 6. B is the short way, 1, 2, 3. And then to write our equation, you do x minus h, quantity squared, y minus k, quantity squared. Now the denominators are going to be a squared and b squared, but which one goes where depends on which way the ellipse runs. Since this ellipse runs left and right, the a squared value goes underneath the x's. The b squared value goes underneath the y's. So since this ellipse is longer in the x direction, the larger number goes underneath the x's. It's shorter in the y, so the smaller number goes in the y. So the foci you find by doing c squared equals a squared minus b squared. So that's going to be 36 minus 9. So that's, let's see here, 27. So c is whatever the square root of 27 is, which is 5.2. So since this thing runs left and right, we're going to take our center point, 2, -4, and to the x value, we're going to add c and subtract c. So it'll be 7.2, -4 if I add, and if I subtract, -3.2, -4. That's the location of the foci. So once again, you're adding to the x's because it's going left and right. If this ellipse had been taller, top bottom, you'd do the same thing to the y's. Add c, subtract c. Okay, so here's just given an equation. Find the coordinates of the center foci and the vertices. So I need h, k, a, b, c. So h is going to be -4, opposite of what's with the x. K is going to be +3. A is going to be 5, the square root of the larger, and B is going to be 3, the square root of the smaller. So to get C, I do 25 minus 9, and take the square root of that number. So C is 4. So the center lies at -4, 3. The foci, so this thing runs up and down, the larger values underneath the y, so I'm going to change the y value by c. So -4, -1 if I subtract c, and -4, +7 if I add c. The vertices, since this runs up and down, are going to change the y value as well by the value of a, so 8 if I add, and -2 if I subtract. So then sketch the graph. So 1, 2, 3, 4, 1, 2, 3. So there's my center. And then this is going to be 5 tall. So 1, 2, 3, 4. 1, 2, 3, 4, 5. And 3 wide. 1, 2, 3. So there you go. Alright, so example 3 involves completing the square. So the first step is the constant term, the number, needs to move to the right. Then you group your x's So this is a little bit different. You group first before you do any division because we're not actually going to divide. Instead, you factor out the coefficient. So completing the square, plus 1/2. Now here's the thing, instead of putting a plus 1/2 over here, this is actually 4 times 1/2, so that's plus 2. This one might actually be unsolvable. So that's going to be 36. Oops. Negative 100 plus 2 plus 36. Yeah, so since I have a negative number over here, it's actually impossible to finish this problem. What you'd actually do would be you'd collapse. That should be 1/4. So this should be a 1, which makes this a 63. You'd factor like you normally would, and then you would divide both sides by this number and set up a fraction, but that can't be done. It won't work out because that's a negative number. Oh, there's the problem. It's because it's 40x, which makes this 10, makes that 10, makes that 25, which makes that plus 100, so this is 36. That's 36. Alright, so now, which makes this is now, should be a minus 5. Let's divide everything by 36. X minus 5 squared. So 4 over 36 is 9. This is over 4 equals 1. And you can find, so H is 5, K is negative 2, A is 3, B is 2, C is root 5, which is about 2.2. So the center lies at 5, negative 2. It's going to be 3 wide, because 9 is underneath the x's, and 2 top and then down, because 4 is underneath the y's. I'm not going to sketch this because I don't have some nice graph paper, but that would be the work to set up the problem. Ellipses have a property called eccentricity, which is noted by E. So you divide C by A, and it tells you how circular the ellipse is. I think these are actually backwards. The closer it is to 0, the more circular it is versus ellipsy, I suppose. But that's the end of 10.3.